Welcome to the workshop, which is CEO porn and how to make it for free. This is okay. How did we come up with the title? Firstly, Georgi asked me for a title for a talk, and he said, "Oh, make it sexy." So I jokingly said, "CEO porn," and he went, "Oh, brilliant." I was like, "No. This is a conference." And he went, no, that's brilliant. But the actual where does the term come from? By the way, I'm English, but I live in Ireland. I probably speak quite quickly. If you have a problem, tell me to slow down.
No, it's okay.
Okay? So, because my accent is quite unusual. So, we go to a lot of data science meetups, and Mick here set up Dublin R a number of years ago. Which is basically, I think, just to get out of the house because he was doing R on his own for work, and he wanted to basically find a peer group of people who could help him. And that's how I got into data science. I got brought to a Dublin R talk by someone I met in a pub because it's Ireland, and that's how I know Georgi as well from Dublin R. And it's a very kind of broad church of people who use R and do data visualization, do lots of weird stuff, and it kind of has grown over the last 4 years, Mick, to be about 1,000 people. Yeah, okay. So one of the guys who used to come along and we got to know him was, he has a company called Beautiful Data. And he does data visualization at he does huge things like topological visualizations of large amounts of huge data sources. And that's what I'm going to talk about a lot on how we use visualizations and how we build them. But he basically coined the term CEO porn, because he basically was doing very specific things for boards of companies, showing them how their customers were walking around, what's going on. Just some really interesting. And he's a mathematician by training, but an artist. And it kind of stuck because it really is an absolute. It kind of says an awful lot of what. One of the things we found is that telling a story with pictures when you're doing data science work is really, really important, okay? Right. Communicate visual, it's not taught in school, but it should be. And when I grew up, I have a very mathsy background, did a maths degree, and trained as an actuary, which is basically, I think. I think I am. I'm working in data and I use computers, so that's basically good enough at the moment, I think. I don't have any professional qualifications. So I'm an actuary, but I've worked in tech for a long time. Anyone who saw my talk yesterday would know. So I've worked in tech since the early 90s. So I've seen everything. I've learned C originally, Pascal, Fortran, COBOL, you name it, I've learned it. Python, Java, more recently R. Languages don't really faze me an awful lot. So I've been very, very tech focused and very, very, on the code, running projects, getting stuff done. And I had no visual education at all, okay? So got into machine learning about 5 years ago, basically by attending a Dublin R meetup. And I met a group of people there who used visualizations all the time. And graphs were just like quickly graph it. And I realized there was a whole area of my life that I'd done an awful lot of work, but I had never really learned to think visually or think how to use visualizations to tell a story or anything. And there was a big gap in my education, I thought, as a data scientist. So I decided to do something about it. Now I'm not basically okay. So I work mainly with insurance companies, right? Which they have a huge amount of data. And it's usually just lying around. They use it for a bit of things, but they also, from a data science point of view, they don't do very much with it. And it's a very, very boring, people have this impression. I think Mick gave a talk yesterday on it. I dragged Mick into insurance, going, you won't believe what's going on in here. And he was like, he didn't believe me. And then about 2 weeks into the job, he was like, this is unbelievable. It's kind of like this, It's an amazing, it's like you're a data scientist in a new world. It's just, and they do use their data, but not very well, and they do it in very traditional ways that, have more or less solidified over the last 40 years. And they, more or less, I'd hate to say this, but it's practically an innovation-free zone because it's a profession, and professions are very, very guarded about what they do. Data science is more or less the opposite. It's not a profession at all. It's a lot of people, using tools, came out of the natural scientists, probably, astrophysics, huge amounts of data. How do we visualize it? How do we do stuff with this sort of, these are the tools, this is how the tools got generated. So they don't really use their data very well at all, and they don't visualize it. So we found very, very quickly, so I work with computers a lot, okay? So I'm very technical. I have no design training at all. I mean, none. My wife's a fashion designer. That's about it. She buys all my clothes. I do like art and architecture, which is like something that, but I wouldn't have a clue how to draw, wouldn't have a clue. I mean, I'm a terrible drawer. I think I gave up art very, very, very early on in school, as soon as I could. So I had no background for this at all. And basically, this talk sets out the journey, basically, effectively. And it's, okay, audience participation is mandatory, okay? What I'm going to do is I'm going to show lots of visualizations that we've done and how we did them and what we, the tools that we used and why we did them, okay? So it's going to be me talking a lot. And then about halfway through, what I'm going to do is I'm going to show you, I had a dashboard up there, which we put together for an insurance company about 2 years ago, using their real data. It was something we threw together very quickly for them. And all the code is on GitHub. I'm going to show basically the process that I went through to get to how I got the dashboard, how I got that stuff up and running, because I had to learn everything from scratch again. And it's actually not that difficult to do. It's like anything, you just bite, it's like eating an elephant. You just start one bit at a time, and start from somewhere that you know. It's like I knew data, but I didn't know how to do, and I'll talk about that. So it might seem a little bit haphazard, but that's very, very much the way that I learned to do this sort of stuff. So along my career, I've tended to learn new things to scratch an itch. I have a problem. I mean, I learned R because in about 2008, I taught myself some rudimentary R because I was working for a reinsurance company, and they were looking to try and model the effect of large-scale epidemics on the population of Europe. And they were using these copula models. So I don't know if any of you got which are basically, they were trying to model them in a spreadsheet, and it was just blowing up the computers. So I Googled copulas, and something from R came up. I learned R, got the package working, and managed to basically test their code using it. And that's why I was like, this is an amazing, and it was fabulous graphing packages, and even ggplot then was very, very interesting. So I kind of learned new languages. Basically, because it's the best tool for the job. I'll learn how to use it. So I don't have a fear of doing that. Okay, but generally this is the way it starts. I have no idea what I'm doing, and that is quite a normal state. If you work in data science at all, every project starts off like this. There's usually an interesting problem. We have some data. Busk it from here, basically. You're literally making it up as you go along. You are, and trying lots of things. I kind of talked about this yesterday. It's important to be able to work in a culture where you can fail fast, you can experiment, you can throw things away. It's almost like a kind of a maker shed kind of culture that's very important. So, but I kind of know one thing, okay, that you can learn anything. So anyone can learn to do this. If I can do it, anyone can do it. Because I'm a coder basically by trade. What I don't have is any design. So I roughly knew what, a lot of the dashboards I'm going to show you is, I'll go back to it now, and I'll show you, is basically, I'll just put it this way because it's easier, is a very, very simple dashboard. Now, it looks simple for a reason, okay? Basically, it is HTML framework. I didn't know HTML. It's not difficult to learn HTML. It's a markup language. But you can do amazing stuff with it. That's quite complicated. So within the HTML framework, we have blocks, and any of these blocks are basically JavaScript. This is a JavaScript package. Okay, so I had to learn JavaScript. JavaScript's, I don't know. Are there any coders here? I don't know. But in terms of coding, in terms of maths background, design background, pardon? Yeah. CSS, yeah. I don't have any of that. Well, I didn't, right? So I had to learn HTML, okay. JavaScript, there's a lot of JavaScript libraries lying underneath this. They're all available for free. Had to learn that. I've got a coding background. That's not particularly difficult. You read the manual. You just practice an awful lot. And CSS, to make it look good. I hate it, but which, as you can see, I have, right. No, I've gone way above that in terms of what I've done is what I did was when I realized, okay, the stuff I did looked absolutely dire to start off with. I basically found some stuff on the internet, and it was, one of them was someone had taken Bootstrap and built some dashboard frameworks from a crowd called Keen.io, and I basically stole their layouts and code and that. So I literally bootstrapped my own kind of framework to actually make this kind of look pretty okay. And then underneath that, there's so having to learn JavaScript, HTML. These are quite specific libraries that is actually running. Underneath this, there's a package called Crossfilter, which I'll go into in a minute, which is a multi-dimensional cube. In terms for basically you can run queries against, it's kind of like a tabular data store in JavaScript, which you can run map-reduce queries across dimensions and stuff like that. On top of that, there's a fabulous kind of another library called DC, which I'll talk about a little bit in a while. Again, it's built on D3. I don't know if anyone heard of D3. Data-driven documents. A guy called, so it's basically taken some stuff out of that, built a framework on it to make a multi-dimensional graphing library. So what's happened is there's a kind of ecosystem of people kind of building this stuff for their own use and then putting it back on the internet. And that's basically what I found. So we had a job where we were working for an insurance company, and what we spent a bit of time learning to do this sort of stuff, just because we were doing, and what we found very, very quickly, that this sort of stuff was absolutely brilliant when we were talking to the people we were working with, because they were trained very similar to me, but maybe without the maths, without the coding background, but they were a business background. So I'm just going to close the door. So trying to explain to them what we were doing machine learning wise and data wise, it's just like, you could just see them glaze over. And what we realized is that this stuff was actually, when we could do this sort of stuff, and then we used it to communicate with the people who were paying our wages, it just worked. They absolutely loved it. And what we kind of realized very, very quickly, a number of jobs, myself and Michael and another guy had a company called Applied AI. And what we realized very, very quickly was that when we went into to do a data science job for a company, it was usually a financial company, we would basically get bombarded very, very quickly. We'd be given the access to the data, which was generally in like 300 bin bags out the back on fire, because most financial companies' data is. It's like a dumpster fire. And they'd be, day one, day two, they'd be like, oh, what have you done yet? What have you done? Have you done anything? Have you found anything? And we'd be like, oh, just go away, leave us alone for a week or two. And what we found is that we kind of said, okay, we built them some dashboards. One job we built a couple of dashboards very, very quickly, which mapped all their policies and where their claims were and what were going on with the car insurance company. And we gave it to them to say, look, there it is. We put it up on a website internally. Off you go. And basically, they went away and played with it for a week and left us alone. We were like, and we actually got some work done. So. And so that's where we almost used it to run into, we realized then it was a great way to run interference, to go in, give people something very, very quickly that they could relate to, that they'd never, because most people have never seen their data graphed before. They'd never seen it graphed like this. I mean, this sort of stuff is, when you could actually just go in and say, okay, show me all my policies in Kerry. And it goes, it's a bit Minority Reporty. And, how do we, this is all generated data, by the way. We kind of worked out a very easy way to actually more or less generate data sets that we can graph, so we can actually show this sort of stuff, because this was done on proprietary data originally. So we kind of realized this was actually a really useful way of working, that we could go in. We have this sort of stuff templated up. Because we've done it a few times, we more or less know what we're doing. We can go in and build these dashboards very, very quickly using open source tools, give them to people, go away and actually discuss what they want to do with it, and basically then more or less buy some time while we clean their data, run a little bit and do some machine learning on it and do some work on it. So it actually became, we thought, okay, this is a really, really useful. So we started doing this a lot more and got much better at it. So I'm just going to talk through the underlying technologies that there's this. I mean, has anyone any experience doing this sort of stuff at all? Building dashboards in Tableau or Tableau? See, we at the same time, this is about a couple of years ago, about when we started doing this, Tableau was absolutely outrageously priced and rubbish. Now, I've just looked at it again. the price has gone down, and it's a lot cheaper, but it's still not free. As a zero kind of cost to entry, this is actually, you can do some really good stuff. It does take a little bit of time. You can actually knock things out, really good stuff out in Tableau very, very quickly, but it is proprietary as well. So basically, this is kind of the route we took at the time, because Tableau was, I think the company we worked for, Zurich, which is an insurance company, spent over 100,000 euros on it at the time, and then about 100,000 on training. That was like more money than we built them in 2 years. So this wasn't feasible. So the idea was get some data and graph it. And basically, as I was saying, all this sort of stuff, all this technology is basically open source, and it's just layered on top of each other. So what I'm going to do is I'm going to take it right back to the bottom of it. I'll start at this is policy data for an insurance company, and these graphs are all from a package called DC.js, and that's built, as I said, built on another package called D3.js. It's kind of a cut down version. And it builds very, 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 very slowly, very kind of logically on that. So what I'm going to do is I'm going to have a look at D3. And okay, yay! Has anyone ever had a play with D3? Yeah, it's a bit of a nightmare. If you're familiar with JavaScript, it's a lovely idea in that it's data-driven documents. How do I get my data? How do I basically meld my data and the visualizations? And it is Mike Bostock is obviously a genius. The guy who designed it. He came from the New York Times. Basically wrote D3 for himself, open sourced it. It's absolutely, and a lot of people have then added to it and you can do lots of, and each one of these has some of them are of questionable use, some of them, but they generally have an example of the data visualization, and they'll also have if you actually look at the documentation, there's great documentation there. There's also some fabulous. A lot of examples, and there's a lot of code that you can use with it. So you've got box plots and stuff like that. One thing we never ever do to people, especially to management, is show them a box plot. You spend the whole time explaining what a box plot is, right? Well, don't laugh. Yeah. And we had another one. I think the last company we worked for, an insurance company, we did a fabulous load of dashboards for them, and they asked us where are the pie charts. We like pie charts. So and we were like, yeah, we don't do pie charts because they're very hard to interpret, unless there's massive amounts of, we generally stick with very, very straightforward, very, very clean design. Never more than like 4 or 5 or 6 things on the screen at any one time. You kind of trying because I recently did. I got a phone call from someone in work who'd gone off and developed, we'd showed him this stuff, and he was like, oh, that's brilliant. And he came back to me and said, I'm having a problem, it's really slow. And I was like, well, why is it really slow? He said, well, I've got 30 graphs on the screen. I was just like, oh, I see your problem now. Said, that's just useless. I mean, it's just, there's kind of, people forget you kind of have to do hallway usability testing with this sort of stuff. You need to go and show it to someone else who doesn't really know what it's meant to do, to see if they can understand it, because if they can't, you've got a problem. You're just wasting your time. So what I was going to say is that, so when you actually start looking at your DC, and it's amazing, and there's some great books on it, which I would highly recommend. There's a great O'Reilly one, which is it takes you through, but at the same time, by the end of that book, you've only got very basic data visualization. You've only got you haven't got a really good, the stuff doesn't look like you could give it to your boss effectively. You've got an understanding how D3 works and stuff like that. But there's a considerable leap up to actually make something that actually looks really good. So what some clever people have done is they have, what have I done? Basically, hopefully the internet, yeah. What a lot of people have done, what some people have done, and they've open sourced it, is they've basically taken some of the stock charts out of D3, and they've basically written another layer on top of it called DC.js, okay, which is I think it's directed charts or something like that, or dimensional charting, right? And what they do they basically is for each chart. There's a very, very simple API, 10 or 15 things you have to set, the size of it, etc., the dimensions that you want to group on and stuff, and you can actually start building very, very nice stuff in JavaScript and HTML very, very quickly. So I was at a data science meetup. It was actually the first one I went to. It was a friend of mine dragged me to Hadley Wickham's talk, which Mick ran in Dublin in 3. And he after the talk, we were sitting in the pub, and he showed me some work he was doing, and he showed me basically stuff like this. Now, this is 2013. I just thought it was absolutely amazing. You know, you've got graphs that, you know, they're all linked together. They all move around. It looked like absolute alchemy to me. And it, you know, it's very, very easy. And he explained to me how he'd done it. And I went basically off and had a look at it. So we set it. And it's actually not that complicated. So one of the things that you have in any graphing library, though, is you've got the visual representation here. All these things are linked, and we can start. There are lots of little handles that we can start. You know, we can start moving things around. So we can start. You know, and you can actually start playing with it. I mean, it's just a joy to, you know, when you see people seeing this for the first time, they absolutely just, you know, they go mad on it. You know, they kind of go, ooh, you know, ooh. You know, they can move this sort of stuff around. And they start playing around, they start asking lots of questions. Sorry, I'll go back to DC. And what you've got with a graphing library, you've got this lovely graphing library that's, you know, you've only got a subset of charts. You've got graph charts, you've got some line charts, you've got some histograms, you've got some, you know, basically you can do quite simple time charts, etc. And you can, you know, but in certain, there's just enough vocabulary for you to actually build something that's not outrageously mad to start off with, and there's some really good example demo code. So that's basically what I took to start off with. I took the demo code, and one of the things you've got is a visual representation, but behind this is data. Okay, now and some way we have to bind the data to the charts. Most of the data we use it's usually the output of some machine learning or some data cleaning. So it could come from a database, but generally we use CSV. So this ingests CSV or JSON, but you could easily make it come from a query. But at the back of DC is linked with another JavaScript library called, this is starting to sound, Crossfilter, which is really the magic behind it all. Crossfilter is an in-memory, multi-dimensional, it sounds mad, multi-dimensional filtering for coordinated views. So unfortunately I can't draw on this, but so what Crossfilter does is it takes tabular data, and this is all there's about flights from airports in the US is the data that they have, you know, to show on the demo page. And what it does is it takes tabular data, so we have a number of fields, maybe 30 fields in it, and loads it up. But what you allow then is you can then specify dimensions along it. So you can say, this is my time dimension for, say, in our case, it would be flights, when the flight went, and the time it went during the day. When the flight actually arrived, the to and the from airports, they can be, you know, and what you can do is you can then build JavaScript filters along those dimensions. So you can aggregate, you can sum, you can mean them and stuff like that. So you can actually then build, what it does is it maps that function across that dimension, and then you can reduce it. So it's like map reduce in memory. It's amazingly, I have a dashboard I'll show you later, which is all the San Francisco crime data. It handles 800,000 data points like that. You know, it's written very, very well, written very, very fast. So you can actually do really, really interesting stuff. So the guys who basically built DC took Crossfilter and took some D3 visualizations and built them together into this package. So you can actually start building very, very, very quick. Once you've got your data, you can choose your charts, you can basically map your data, and basically you've got a chart. You can basically say, okay, give me these charts, and then you can basically plop them onto your HTML. And they're all because of the way that it's all wired together, if you click one, it basically applies a function down the cross-filter dimension, and then basically updates all the charts around it. So it actually takes care of an awful lot of the insane plumbing. So it's actually quite straightforward. It took me quite a while to get my head around it. I mean, just a lot of playing, and as I was saying, like, I have no idea what I'm doing. Like, and that's, I mean, if you're developing or you're encoding, I think, or if you're especially involved in the data space, there's an awful lot of that. A lot of time is spent trying things out. Just to show you the sort of functionality, they've built some very simple graphs. So we can slide over. So once this is moving, what it's doing is basically applying a filter down a dimension and then updating all the other dimensions. So it's actually quite nice. Now it is a little bit hard to get your head around, because it's basically that map reduce kind of paradigm, which is, if you come from a functional programming background, it's probably not that hard. But it was a while since I'd done functional programming, and so it took me a little while to of playing around to actually get my head around how it actually works. Okay. Okay. So we can actually start pulling pulling the data up, kind of querying the data and then visualizing the results. So basically, what we've done here is that we have I'll pull out the data set. It's pretty. I mean, it's pretty. Each piece of JSON is basically just one policy line. So it's literally policy ID, what the county name is, what the kind of we have to make the mapping work, we have a cluster, basically a kind of a location ID and stuff like that, and some policy policy start date, policy end date, what the premium is, because it's just policy data. So very straightforward. It's effectively CSV data, and basically, a lot of it's run within JavaScript. So basically what I'm doing is I'm basically loading my policy data, which is just loading, this is what my policy data is. It's I've got some config stuff here, which is I've just put it in a JavaScript object. I've got a spinner, which basically makes, does pretty things while we're loading the data. The data is actually very, very big. The data zip down is about 40 megs. So it's pulling in a couple of 100,000 rows of data, okay? And then what it's doing is, what I've done is using DC, I've basically told, this is using the DC library which I've referenced. Basically, I want a bar chart, and this is the ID that I'm basically bunging that into within the HTML. So I've got a chart type, I've got a row chart, two pie charts, which are the two things at the bottom. So number displays, which are the two kind of the number counters at the bottom, and I've got a table at the bottom, which kind of features. So I basically set out what all my things are. Then what I do, I'll leave the map up for a minute because it's a bit. I'm gonna. And the policy layers is okay. Right, is I load my data. So basically, this is me just loading the data loading it D3. Using D3 has this fabulous kind of little function. You can just load the data, and basically we just pass that to a function. And then what I do is I basically load that data into Crossfilter, which is literally that line. So what it's doing is it's loading that data into Crossfilter, loading it straight up. It's got 5 or 6 different column fields in the data, and then what I'm doing is basically I tell it there's a policy status which is in force or lapsed or something like that, and this is a car type. This is like whether it's a four-wheel drive car or a Jeep or something like that, whether they've had a claim on it, as in has they crashed the car and stuff like that. So basically, what I do is I tell it the dimension, basically tell it, what dimensions am I interested in? So basically then, once I've kind of called them out, okay, which there's a number of them, and then what I do is all I'm doing with this is I tell Crossfilter basically what I want to aggregate on, effectively. So I want to look down those various columns. And then what I do is then I just start basically using DC. So I've got various kind of little functions that I want, and min and max and stuff like that. I format some, and basically these are just things to format it. And then basically what I do is I start this is actually the meat and potatoes of everything. You basically you say, okay, I've got a chart, which is that histogram you see in the right corner, where I want the width of it, the height of it, what the margins are, what the dimensions is. It's basically like what am I graphing on the x-axis, which is the when the policy started, okay. And basically, what am I grouping by? So what's the height of it is? What the actual height is. And basically, I've got some very bits and pieces where I'm saying, look, I like the whole way, because it goes, when you press one, it goes and moves. So it actually looks quite, it looks quite slick. So you just basically tell it, okay, do that transition over a period of time. And then there's a few things I can put in there, what the label is, what the number of policies is, and I'll switch back to the actual. Go on. Yeah, sure. Yeah.
which was given out from Crossfilter.
Yeah, in fact, no. Basically, what you do, because Crossfilter basically is it loads the data into memory, into it, and what you do is you say this dimension, right? So you say I'm interested in say it's a time dimension. Okay. We call that, we give that dimension a name effectively, and what you say then is that you actually say is that I can then apply a function to that dimension. Do you use pandas at all or anything like that?
Yeah,
like that.
It's
It's a very similar idea to that. It's like, it's basically mapping a function on. So you could say, give me the sum, okay, or you could say, give me the average, or the max, or the min, or some crazy function. You like, give me all the people over 7 foot tall, that kind of. Yeah, and what happens is that basically that function is applied. Any change that hits the top of that, say if I filter down another dimension, it reapplies this function, but it doesn't. Yeah, effectively, yeah. But the great thing about it is it takes care of all that for you. It's kind of once you kind of say, okay, I want this dimension, this function on that graph, and see that. But these are all grouped together. So now if I say show me all the I say show me all the males. It basically filters that dimension by M, but then tells all the others to filter, basically cross-filter and reapplies it, and then tells the graphs to update themselves. So it's quite, there's a lot going on down there, right? You don't really want to be doing this on your own. And it took a little while for me to get my head around, but at the time, we had lots of time and no money, which is, so it was, and we had to kind of do this sort of stuff. We were finding we needed to be able to tell people, we need to be able to talk visually. So this was a story that this was a journey that took us about a year of experimentation. We got better and better at it. This is a very simple one that I've just kind of, just to show the kind of the core features of how we actually did this. And then, very simple stuff like there's a great, because of Node, there's an incredible ecosystem of JavaScript stuff, of packages in JavaScript. There's a brilliant one called Chroma, which is basically, if you used like color brewer palettes in R and stuff like that, it allows you to map a color over a dimension, so over a scale. So from 0 to 100, and it will basically, if you say 100, it'll go, oh, that's that shade of green, or that, and it'll map it. So there's a nice, so I basically stole this little kind of JavaScript kind of widget, and then basically linked it to the graph. And again, a lot of this stuff is, getting something working and then making it look pretty. So if I go back to my place of showing code, so that's basically the time chart. So you actually see, you've got a year there, a number of policies. Okay. And if we go back to there, we've got year here. It's basically along here. And basically, so yeah, and you've got the same thing here. We've got this is a bar chart. So we go down and have a look at these other charts very, very quickly. Okay. Status chart, car type chart. Sorry, claim chart. So this is a claim chart. Is the radius? It's actually this thing is actually we specified it as a donut chart. So it's got two things on it. It's got so we tell the height and the width of the chart, the radius, the inner radius, the dimension, basically what we want to map over again, and basically what, and also what the title is when we roll over it. So it's quite straightforward. And again, all this code is absolutely, take it away. It's on GitHub. You can start playing with it pretty quickly. It should work straight out of the box. There we go. If I go back to the actual dashboard, so there we have that is that donut chart there. Then when you roll over, it tells there's a little function that tells it to come out. I know I basically built some buttons, stole some buttons from some Bootstrap thing that someone had done. So literally, this thing is, it took a while to get here, but it's all built out of more or less kind of like, it's almost like IKEA. It looks great, but we built it ourselves from, just chaining together a few libraries. It looks quite clean. I mean, that's very, very deliberate. When we did this originally, it looked shocking. It was all over the place. We then kind of basically said, okay, we need to come up with a way of actually getting that, of actually making it look good. So where we go? No. So I'll go back a minute. Sorry. Let's show that one. Database. We go. Is it key? Yeah, here we go. Sorry. So I'll do this. So what I found just by looking at this sort of stuff, looking for like something where they on GitHub, these guys they sell some quite fancy products to do with kind of dashboarding. Look, and they basically provide a kind of free to use kind of Bootstrap based dashboard outlines, and if you can see that looks very, very familiar because it's exactly what I used. I just basically took one of these and basically used their basic for, and then basically just dropped my graphs into those. So I actually kind of, most of that stuff was, it's almost like, it probably isn't, there's a program in England that was on, and it's called Scrap Heap Challenge, where they put a load of people into like a scrapyard, like some engineers, and they tell them to build a submarine in an afternoon, and then they film it, and it's just, yeah. Well, this is that basically, done in code effectively. Yeah. So there isn't a huge amount of art. It was kind of like keep it simple, don't steal whatever you can, reuse other people's stuff, and work on it as much, basically, and solve your own business problem, but don't try and solve those problems because they'll take you a long time to figure out. Try it as much as possible. So the actual code of this thing is actually not very big in terms of the meaty bit of it is, I've got 300 lines of JavaScript, and a lot of it's boilerplate. A lot of it's kind of like just saying what the actual what the charts are. There is a certain amount of CSS in it, so I'll open actually the actual file. And likewise, it basically we've got this is the head file. It basically, as you can see, I've used a bit of Ajax. I've got some Bootstrap. I've got some. I've basically got that button stuff. I've got I've got basically looking at very various things. I've got lots and lots of kind of references to CSS. Very straightforward. Very straightforward HTML. Everything references to CSS. So basically, we've got containers, which are the Bootstrap stuff. Again, because I stole this from Keen. And I'll find a. Actually, I'm probably looking at a. Actually, what I'm doing is actually looking at the wrong. All these are very similar. So, what we're actually looking at, if we look at policy start date. So here's basically all we've got here is it's Bootstrap. We've got a chart. We've used this as a Keen thing. It's just Chartwrapper. Basically, what I called it, and basically what I've done in basically is I've basically put the time chart in it, which it's just an ID, and what it does is it creates the JavaScript. The DC.js creates that JavaScript in the basically and the SVG and the DOM, and he basically just injects it onto that. So basically, when you actually run it within that, it basically puts it into there. So very straightforward. Okay. A little bit of CSS, which is, the CSS is tiny. There's bits and pieces, very small. Just what we've done, and all I've done is basically set them padding and the background colors and stuff like that. I don't really know CSS very well. I tend to change something, look at it, looks okay, stop. Because it. What you get into that kind of not being a graphic designer and you have any kind of, when you start with CSS and you change something over here and then everything falls off over here and you're and then you move back and that falls over, it just turns into a comedy. It's I just find it incredibly frustrating. So I generally try to do very simple stuff and then don't fiddle with it anymore. This is, not one of us are a designer by any means. We've no kind of design training at all. So, right. So, this is basically what we did. And we have done this. Okay, here's another. We did that kind of stuff about a couple of years ago. And then we realized I found this amazing graphing library called Leaflet. Has anyone used Leaflet at all? JavaScript graphing library for free. It's just mind-blowingly good. And what you can do is it allows you to specify and basically it uses an ArcGIS server with map tiles on it. You tell it the center of the map, the scale of the map, and it'll basically render it. But it's got a lot of stuff in it that you can say, okay, if you have geospatial information, as in which basically for a lot of we have in Ireland we don't have postcodes, but you can geocode. You can actually geocode people quite easy if you have their addresses. Now Irish addresses are quite pathological because it's quite a small country. I don't know what Georgia's like, but I suspect it might be similar-ish. That, people kind of say the addresses can be like John, who lives next to the post office in the town where they have like a blue. It's not actually. So it can be quite difficult to get geospatial information. But in the UK, there's postcodes, and postcodes are about 16, 17 houses. So if you have a postcode, someone has thankfully reverse engineered the postcode information to got the centroid of each of those postcodes. So very, very quickly, if you have someone's postcode, you can basically produce something like this. Really. So we did this for an insurance company in, as I was saying, in Ireland, where they insured. They were a very, very specialized insurance company that insured very, very high-risk drivers. So people who've had accidents, people who've had multiple accidents, people who've been banned for drink driving, that sort of thing. And their insurance premiums were very, very high. It's a legal requirement to have car insurance. So so they only had maybe 60,000 customers, but basically their premiums were. The premium roll for the company was like 100 million a year, so everyone was paying 4,000 or 5,000 euros a piece to be insured. And what we did is we basically we took their data very, very on the first day, cleaned it up, and what we did is because we had the postcodes of everybody, we also knew when the policy started. We knew what they actually had a car type, which they basically put that, which was like whether it's a performance car or a family car, the total number of policies. Number of claims, etc., etc. But we also had where they lived as well, and whether they'd claimed or not as well. So what we did very, very quickly, we basically took that data. We because we'd done this a few times, we were able to put this together in an afternoon. And what we did is because we got Leaflet, which is as I said, it's a JavaScript mapping library, and we basically got it. We basically wrote a little bit of code so we could connect it with Crossfilter. So when these things move, or this moves, it updates both sides of it. So what we did is we showed them really, really quickly. We filtered out where the claims were. Now this data is actually fake data. We've generated it. But we can. One of the great things about this is, it's very Minority Report. You kind of go in. What we found, like especially in some urban areas in the north of England, there was an awful lot of claims that were actually very, very close to each other in space. As in geographically close to each other, but separated over a period of time in terms of 18 months. So they had never seen their data like this before. We were able to do this in about a day, literally from standing start. And we did it basically said, like, go away so we can actually we can work out, go away so we can actually find out where the real fraud's happening and stuff, like use some machine learning. So we actually gave them this stuff. And the next day, they came in and we started saying, well, they noticed that there were claims within the same geographical area, very literally in the same roads, but 18 months apart. And the people who were investigating their claims had not really realized that. And it was completely obvious when you looked at it on the graph, when you graphed it like this. So graphing your data so we were like, that, they were like, that is a fabulous marker for things like, that person has an accident, they basically, or we paid up really quickly, they get insured with us, their neighbor gets insured with it, and then they crash into each other. You find that a lot in car, within things like car insurance claims fraud. There are a lot of connections there. So day two, they kind of came back to us, and the managing director, the guy who worked for the managing director, said, yeah, I showed him the stuff, and he said, can the managing director get that on his phone? He wants to show his mates on the golf course. And we were like, oh, yeah. So we knew we were doing a relatively good job then. But being able to do stuff like this very, very quickly, when you get into a job, actually really when people are hiring you to do data science and do data, it's very woolly. If you can actually give them something very, very quickly that's very, very useful, that doesn't take you a lot of time, you get a lot of buy-in very, very quickly, and you kind of get that kind of, okay, these people must be okay, they know what they're at and stuff like that. If you can actually start telling them stories about their data that you shouldn't know because you've only been in there a day or two, it has a very big effect on this didn't actually work out very well for us in the end. The story is after about 3 weeks' work, we got, they asked us, they said, thanks a lot, we've had enough, we thank you for your help, and they asked us to leave, and they paid us, and we were like, well, what happened? They must have just changed their mind. And we discovered that because we had done stuff like this so quickly, the guys who ran the company were afraid we were going to take the company off them. They thought we were going to, we were like, I only found that out the other day, actually, because they thought, if they can find out this much so quickly, what could they do here if they'd been here a month? It didn't even occur to us, but there you go. So and then you basically once you can actually build. You can actually we've got nice little bits of where you can actually you actually see the the actual policy information. We've actually got what where they live, what the sex is, basically where they what the car type is, etc., the postcode and stuff. So we can actually build up some quite very quick information, and actually make it very interactive. So really simple tool to actually put together. And I'd encourage you to start. I mean, the really only way to do this is to start playing with it. Take the code, break it, add some stuff to it. So on the other, what I'm going to do is I'm going to show one more. This is kind of like this is something we did for Dublin R, which I was involved in, which Mick runs. We had a data science competition. When was it? About a year ago, 18 months ago.
No.
And one of the things, we took a Kaggle data set, which was the San Francisco crime data. There's 800,000 basically crimes in the San Francisco area being loaded. That's how long it took to 800,000 of them, right? So and build a heat map and basically, so you're seeing 800,000 points basically mapped here, okay? Now some of these tiles are taking a while to download. I suspect that's the internet connection here. It uses a kind of a map server that's open source somewhere else, so you'll probably see the tiles come down slowly. But it's basically graph the data. So what we did, the challenge was take the San Francisco crime data, which is I think it's 1.6 million crimes. I think they split it in two. Train and basically let's do whatever you want to come back and talk about what you did with the data. And one of the things, because I was learning this at the time, what I did was I said, well, I'm going to go and basically do everything I wanted to do with these graphs and teach myself a lot more, and then come back and show what we did. So basically, this is, as I said, it's 800,000 different crimes, and basically we built a nice overlay, again, CSS, and we've got, okay, what I did was I took the data, so we've got the time of day when the crime actually happened, okay? What I also did was, I worked out what day of the week it was, right? Also, what district it's in, because it was basically by district, because we had all this. What the crime category was, which is basically, it's got larceny, other offences, non-criminal, assault, drugs and narcotic, vehicle theft. It's a laugh a minute. And basically what happened, basically a resolution, whether it was a psychopathic case, unfounded. Now, there's some interesting stories in this data. So I was just doing this as a kind of like, I want to make it look kind of like a bit like Minority Report, so I wanted to do that sort of stuff. Just, to teach myself a bit of CSS. So we can say, okay, let me look at the crimes that happen. What I did is I took the data. I actually worked out, because the data is CSV, I took the data set, 800,000 crimes, it had a time on it. So what I did, because I had I was using pandas to format the data, I got a piece of code that astronomers use to work out whether it was day or night. So I put in the lat long and then basically said, is it day, night, morning, like twilight or early morning, to see if there was any difference. I also looked at phases of the moon to see if there was any correlation between crime and full moon. Nope. So, but maybe I was still hoping for that, right? And then you can start saying, okay, show me all the crimes that happened in the day. Yeah. So, and it comes down. On a Friday, and where the psychopathic cases.
Can you select multiple points? Like, show me crimes that happened during day, and where psychopathic.
Yeah,
cases.
okay, yeah.
Oh well,
Yeah.
no, that's what you did, right?
Yeah, that's what I've done there. So.
But can you say
Well,
there's a time there? Can
Yeah.
you select like day and noon at the same time?
Yeah.
Oh, okay.
Yeah.
Cool.
I'll show you now. Let me just reset all these. So that is, but it's quite slick because you've got 900,000 crimes, 900,000 data points, and then that's basically there's a heat map layer which is built into the mapping library, which is Java. Basically, and what I've done is I've got a heat map, but once it goes down past a certain, I've kind of split it. So once it goes down past a certain granularity, the number of points, it basically splits out into like a marker cluster. So then you can go down and down and down. So if we go down and down and down, it's going to take a little while to. Yeah. Again, I'm going to put this up on GitHub. so you're free to take it away. There's lots of, this actually has got some use in that. I met a guy at a conference who models earthquakes, and he was looking to do it, and he was like, do you have anything that I've got like 1 million data points? I was like, I have exactly what you need. So, we can start looking at, if I reset the whole thing, there we go. A lot of crime. Now, you can tell some very interesting stories with this. And I used to live in San Francisco. And this area of San Francisco is, have anyone been there? Yeah, downtown, okay? Yeah, Tenderloin, Mission. I used to live in the Mission. That was in the 90s. It was drive-by shooting a lot. It's much more gentrified now, thanks to Google. And the Tenderloin was just a no-go area. In Civic Center, which is the center of the Civic Center, there's an awful big problem with homelessness in San Francisco, and a lot of it is basically people who have, should be in residential care. A lot of psychiatric industry, a lot of psychiatric cases. So one of these things is a psychopathic case. So I had a look at that and went. And that's exactly where you'd expect it. It's literally, the hot spot is exactly where I remember wandering around, and it's just people who are homeless because they are basically mad, and they can't look after themselves, and and it's kind of like it tells a story within itself. And again, one of the things we looked at was if you were to commit a crime in San Francisco, where would you do it, and what would you do? So we actually say resolution is none, right? So we kind of worked out that if you are going to if you have to commit a crime, there's 156,000 larcenies, which is theft, right? And basically, which is theft. People. That's what the Americans call like petty theft, like breaking a car window, stealing the radio, that sort of stuff, right? So basically, if you are going to commit a crime in San Francisco, steal stuff, because there's only about 90% of the people, 90% of the time, you'll get away with it. Pardon? Do you want mugging? I don't know. I will go for. Let's find out. Yeah. Okay. There's how many of them there are? We'll just say vehicle theft. Yeah.
Okay.
Missing persons fraud. Okay, but let's just go for let's go for assault. It's close enough. Yeah, basically you're. Reset that. So that's it. I mean, none booked. So basically, about a third of them are basically arrested. But you can actually tell, during this, you can actually tell some interesting stories. Everyone has lots and lots and lots of data. They have lots and lots of, in the companies they work in or whatever. This is actually, if you don't want to go down the machine learning route or predictive analytics, this is actually a really interesting. It's actually quite fun because you get to tell stories with it as well. But it has a very, very good practical use. So, and again, you can see the assaults are all. I mean, were you here by any chance? Victor, where were you living? Where were you staying in San Francisco?
On
3rd Street. Yeah. Okay. Yeah. 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 I mean, when I lived there, this area was China Basin. It was where all the good nightclubs were, but it was an absolute no-go zone. It was nuts.
We tested your data.
Okay. So, and again, this is like you've got big high-dimensional data, lots of it. These techniques are really, really as an initial view, this is the way to go. And
be on a sample of your data.
Yeah, and
Don't try and plot 100 million data.
Yeah, start off. So, I don't think of anything else. In terms of just general visualizations, one of the things that we use a lot to do the presentations is reveal.js, which is a JavaScript presentation framework. So you can do some very, very interesting stuff in it, and you can actually embed visualizations in your presentations. So it becomes you can do some very, very slick stuff, which is another, again, using the stuff that we've just done, which is kind of DC, D3, D3, we can actually start doing some really, so one of the things myself and Michael did, we did a talk at an actuarial conference a while ago, and if I can find it, all right. So, I think it's probably in here. It's is it Siggy? No, Siggy. Yeah, Siggy. Yeah, here we go. So, the reason I'll show you this now is because we did a talk.
Come to my workshop tomorrow. We'll see this in more detail.
Oh yeah, you're gonna.
gonna use
Oh, do you want me to not show it then?
No.
Oh, fine. Okay, fair enough. Right. I'm gonna steal his thunder here. 'Cause I just want to show that you can actually. This is a company both of us used to work for. They're a firm of consultant actuaries in the city of London. They mainly deal with pensions and insurance companies. So we did a kind of a jokey talk called Bayesian Statistics in 5 minutes. Which is impossible. So let's try to learn about Bayes rule. This was to a bunch of actuaries who should probably know this stuff, but don't. So what is Bayes rule? So you've got nice JavaScript. So you use Bayes rule all the time. Shows how your beliefs change when you get new information. Let's start with something familiar. Tossing a coin. So toss a coin a few times and tell me if the coin is fair. So it's usually, you can assume the coin is fair because it's very hard to find an unfair coin. So if your first toss is a H, is it fair? You go, yeah, it's heads. Second toss is heads. Is it fair? Yeah, go for that. Third toss, fair? Yeah. Fourth toss? Yeah, maybe. Starting to get, fifth toss is a head. Yeah, okay, I've had 5 heads in a row now. 6th to 10th toss are all heads. Yeah, I'm definitely, something's going on here. The 11th to the 20th toss are heads. Definitely not fair. The chance of it are basically 1. So you started off believing that the coin was fair. That's your initial belief. In the end, you went, yeah, it's not. So basically, you've just applied Bayes' rule without realizing it. You've basically updated your beliefs as you got more information. Okay? So the reason I'm showing you this is we did this and we explained it, but then we kind of go, okay, a picture is worth 1,000 words, and then this is, and basically this is exactly what we're trying to do. It's a D3 graph effectively where we can show what the effect of the updating is. So what we've got here is that we've basically said, what we're saying is this is our prior belief about the coin. So we're basically quite sure that it's fair, but it might be, might not be. So we've got quite a strong belief that it's fair. Now, if we tossed heads 20 times, tossed the coin 20 times, and got heads 20 times and tails no times, what will that do to our belief? So what we did was bang, and it's basically this is what our prior belief was. This is what our belief is after we've tossed the coin 20 times, and we basically think, oh my, using Bayes' rule, we've got a very high probability of it being an unfair coin. Okay, and it actually hasn't shifted that much, but this gives you a way to show that. And Mick's going to talk an awful lot more about it tomorrow morning. But you can actually embed that visualization framework within presentations. It makes it, if you can do that, it's actually quite. It takes a little bit of work, but it really, for doing, doing stuff like, talking at conferences, or you're talking to, you've got high net worth clients. We deal with a lot of people, like in reinsurance companies and insurance companies. It's very, very powerful tool to be able to embed this sort of stuff because it's just HTML and JavaScript. And I'm trying to think of anything else. One other thing is this is quite odd. And I think I will, is it? I don't have it here. Right, we did some work with an insurance company where they gave us some of their emails. They gave us a year's worth of their emails internally. And they kind of went, could you do anything with this? So we went, okay, I don't know. We had a look at it. We looked at things like, right, we had an email, so we had a to and a from. So, and also we had an organizational chart, so we could tell who was sending what to who, so we could build a network diagram very, very quickly of who was sending what. We also had the text of the email, so we could look at natural language processing tools. So we looked at, first of all, we looked at sentiment analysis, which is like, what is the tone of the language? It's very simple. And then we also looked at using topic modeling, where we applied topic modeling techniques, which is a Bayesian technique where it basically looks at words and things that co-occur together, and then says, okay, these things tend to co-occur, these things tend to co-occur. It doesn't tell you what the topics are about, but when you actually look at the words that kind of come together, you can say, well, that's mainly people complaining about stuff. So what we actually found was, there was a lot of a lot of the traffic was like internal by department. So one department might be emailing itself like multiple times, people within, and also we saw various topics where people were complaining, certain types of contracts tended to have a lot more complaints. The language tended to be an awful lot more aggressive. And we could see what you've got a year's worth, you had 600,000 emails. You could actually see what was going on in the organization without actually having to ask anybody. It was quite, but we had to figure out a way to actually demonstrate and talk. So we had to think about how do we demonstrate that, and how do we show that kind of, and we were like, okay, well, we'll have to basically find some visualization. So, wait a second. Hopefully this will come up. It looks like the, is it? Oh, yeah, there you go. Yeah. So, again, I'm just going to go quick. It's actually a talk we did. So basically, we got a lot of emails. Can we do anything with them? So we looked at natural language processing. We looked at the email network. We looked at the sentiment. And we looked at the topics. Okay. Results were alarming. We can't show you because it was an insurance company. So we found Enron, which was a large energy trading firm in America that basically went and it was a huge accounting fraud in the early 2000s, and it filed for bankruptcy. It was the biggest bankruptcy ever at the time. Lots of executives went to prison, destroyed their auditors, Arthur Andersen, and absolutely wiped them off the planet. After the court case, though, the federal government basically released all of Enron's emails going back. So there's 3 years of emails from the top 150 people in Enron, and it was an actual company that was going off a cliff. So there's 1.7 million emails. It got altered the day-to-day business operation, lots of gossip and personal details in the emails, quite a few affairs, people being pleasant about each other. That's what happens. And we were like, brilliant, let's take the work we did for the insurance company and run it on the Enron stuff. So this is what we did. We did the machine learning on it. We took the data, and I'm going to show you. And then this is where I'm talking to you about the dashboarding. What we kind of did was we built this D3 again. And it's an email network, basically who's emailing who. So, and you can think about any kind of network. And because it's D3, it's nicely, this is this guy. This guy is Rick Boy. I think this guy's the CIO. There's people in here. You can see there are people who are very, very strongly connected. And a lot of and what you can see is, because I don't have it on this, but if you do it over time, they get more and more connected. And the people like the CIO, the Chief Information Officer, the Chief Investment Officer, and the Chief Risk Officer, their communication gets whoa, and then bang, the company. So you can actually see what was going on. So we did this on a department level for the insurance company. So we knew the claims department and then sales department, and you could see massive amounts of emails going to each other. And they went by and actually used this visualization to change the way that they ran their business. So the next thing though is the topic analysis, right? And again, this is the visualization of what's going on in all those emails. So what we've done is we've taken all of those emails and we basically run some machine learning software, and it's sorted them into topics. It said these words co-occur. So what we find is, I think we have one called gossip here, which we kind of looked at it. And because they said, these topics, it gave them a number. When we looked at the words that were in it, we just called this one gossip. Because it basically had things like, maybe it's the other one actually. The other one's got, I think that's casual conversation or something like that. Because it's got things like drunk, crazy, kid, cat, all these words that co-occur. It's just people just telling each other what they did at the weekend, into Little League and stuff like that. But this is how we did this, and you can actually see this topic is pretty standard, but it goes up and down a fair bit. And you actually find, when you actually look at what's going on in Enron, basically, these are really bad points where they start, and then it just died. Enron went out of business here, basically. So you can actually see, if you actually look at some of the stuff that's going on, like financials, and I think there was one that was very, 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 we can actually start looking about what is actually going on within the organization, within various topics, and basically, when are they actually happening? Because we've got that thing. So we're using dashboarding and using DC again to actually get a view on something that's absolutely more or less impregnable to actually, so running machine learning software on it, and then basically using visualizations to communicate the results. Same technology, absolutely the same process, just a slightly different. As you can see, the DC stuff I showed you on the website looks very, very similar. We basically more or less stole it off it. So now we can actually see who emailed who. So we can actually say, if this is from we actually knew who was a board member and who wasn't, because we didn't have an org chart, but we had a good idea about who the main protagonists were in Enron, so you can actually see what's going on. So very, very quickly, you can actually, I think some of them were, I reset everything, reset. So you can actually see words that actually come together. So we kind of very, very quickly you found like very, very, very quickly. I mean, this one we found very, very, very. I just wanted to thank you for cutting off financial report for Europe. I'm pleased to say that as from today, I'm no longer employed. I'll be explaining this to my 3 children tonight. They want to understand why Santa won't be coming to their house this year. So it's just basically an email in there sent from a guy who'd just been laid off by, and we found out like literally equivalently, like basically his Hotmail address was upsetandjobless@hotmail.com. And so very, very quickly we were able to dive into, and this is the one thing it doesn't have at the moment, because we haven't really, the natural language processing is not very good with like sarcasm. It's when people say things like a world-class team indeed, I don't think he meant it. But the computer doesn't know that. I'm sure that'll change. So this is an idea about how do we visualize flows of information and stuff. And we kind of made this up. We didn't have a plan on how to do it. We kind of figured out that this kind of worked. And that's my talk. It was a very rambling, and it was kind of like lots and lots of stuff going on in there. I'll put the code for the San Francisco stuff on my GitHub. The car insurance one's there at the moment, and have a play with it. That's all. Yeah.
I wanted to mention that we were when you were showing the diagrams and stuff.
Yeah.
You were mentioning the context actually, who was who
Yeah.
and
Yeah.
what happened. It would be. I usually find this kind of fascinating visualization online, and they all like this context.
Yeah.
Because I know the name of the company, and they committed huge crimes of centuries
Oh, yeah.
of geotag.
Yeah.
I don't know any names or even times frame. It would be much more useful for people if you publish if there's some line like investigation started against.
Yeah. This was a presentation I threw together for work. They asked me to do like a funny presentation about data scientists to a load of their clients. I was like, oh, okay. So this was about the only thing I could think of. The one thing we haven't looked at, and I showed you, Victor, know this, is we did some work on the Irish census data. And again, what we did is we were working for an insurance company. They wanted to ask us about socioeconomic kind of modeling, because we figured that the socioeconomic makeup of the country figured out it might have some bearing on how long you will be, how good a customer you will be for the insurance company, how long will you pay your premiums for. And we thought, okay, let's go and ask one of the data companies, and they wanted to charge us, I think it was €250,000 or something like that, which was a phenomenal, more money than we'd spent setting up the whole data science operation. And so what we did is we took the census data and we had a quick look at it in Ireland, and we ran some clustering algorithms on it, and then went back and figured out what the clusters meant. And then this is how we discovered Leaflet. And when we threw it onto Leaflet, we have all these small area maps, so you can actually start seeing.
What kind of census are there?
It's a population census every 5 years in Ireland. So what happens is you get a form in the door, and it's all electronic now, and you basically have to answer questions. Like, it goes on, it's about 20 pages long, and if you don't fill it in, you go to prison, because they're really quite militant about it. And but from that you get, each one of these areas, these green, is called a small area map. That is the smallest area that the census people will actually give you aggregated data for. For each one of these, you have 700 data points. So you have count of kids under 5, count of kids under 7, how people who commute less than an hour to work, more than an hour. It just goes on. So you have this very high dimensional data set, which we managed to reduce down, clustered, and then basically built out. When we kind of clustered it into 12 clusters, and then we went back and looked at the clustering algorithm, and the clustering algorithm. So if we actually look at, say, this is Dublin, which is where I live. Okay. I'll move this across a bit. Yeah, again, the rendering is quite slow because there's a lot going on in this map. There's 18,000 of these areas being drawn, and within them there's quite a lot of information. So if we actually look at the Dublin, which is the city centre of Dublin, you've got all these yellows. And when we looked at what our clustering algorithm, that basically is like all the yellows are broadly similar. And when we went and looked, we built some visualizations internally for ourselves to actually figure out what axes in the census data it was clustering on. And we found that basically these were the rich professional people. These were your accountants, your lawyers, your architects, all the A's, actuaries, attorneys. The greens, the dark greens, are really interesting because they're very young people, and they are strongly non-Irish, and they're very well educated, and they all work in tech. They all work in Google or pharma. It's quite because they don't commute very far to work. They walk to. They live in cities. They're almost like and they're more a phenomenon of the last 20 years in Ireland because. The industrial the growth of the tech scene in Ireland has been quite meteoric in the last 20 years. So we actually use, but then we use this visualization then to actually show the company we're working for when we actually mapped their policyholders over it. Now I haven't done that, but what I've done is I've mapped their house price data over basic. This is during the financial crisis in Ireland. This is about 2011. So basically. This is like the house sales over a 3-year period. If you lived in Dublin, you could sell your house. You lived anywhere outside Dublin, you couldn't give your house away. The country just stopped. So that's basically why you're seeing a huge concentration in Dublin. Now, even adjusted for population, that's actually quite scary. And when we did this work as well, and we've taken the policy, maybe the information from the insurance company, and then mapped it back on it. You can actually see that the people who live in various areas some people have much better. Basically, are much better customers, and it's I can't say it's a causal thing, but there's a correlation there between socioeconomic status and how good a customer you're going to be for that insurance company. So again, visualize it using Leaflet, using D3. This is a D3 thing that I basically stole. Again, a lot of it. This is all built from bits and pieces. So. And it was mainly the result of a lot of strangled crying in the dark and some playing. Sorry. Okay, I've definitely done now. Right. Any questions?
How many people do you have usually in your team?
At the moment, I'm working in a small consultancy, and there's 2 of us. Now, when we were working, myself and Michael were working in an insurance company, there were 3 of us. Right? So, open source is like having the biggest tractor ever. You can just lift anything. Makes very simple jobs. Very hard jobs, very simple. Go on, yeah.
Question about
Who's that? No, go on, go. Yeah.
Question about the loading of the data.
Yeah.
As I assume from your talk, mostly it was in-house presentations to the organization leads.
Yes, some of it was. That's why. Yeah.
How it can work and how can it be kind of optimized to present to the outside customer when you are going on to the loading 60?
Yeah. Well, you cache it basically. What you would do with this stuff is, at the moment, this is just done rendered in browser. It's on my computer. I would do this in Node on a server, and then basically just serve the SVG straight up. You just push it down a bit. You could do that, or use something else like Tableau, or pre-compute stuff. This stuff is really, here's a visualization of your raw data. What do you want to do with it next? But it's high quality. When we've shown this to people, they've like, we'll want to buy this sort of stuff straight away, and we're like, actually, it's great for in-house stuff, but if you were to productionize it, it will take a bit of work. Yeah. Go on. Yeah.
This is so amazing what you do, but then at the same time, there is another tool, Power BI.
Oh yeah, I looked at Power BI recently.
And it's free, actually.
It's yeah, it is. Yeah, we looked at Power BI recently, and it does a lot of this stuff, but not quite as slick. And again, this sort of stuff was. We did this. This map was done 3 years ago, right? Yeah. This stuff goes old, but I'm just what the D3 stuff is amazing because it allows you to do. Again, you're only limited by your own imagination. You can actually do some really interesting stuff if you want to, and it's free. And then you can say, if I was going to productionize this, I'd go, Tableau, no problem. Yeah. There were a lot of things I had to get my head around.
There's a new language,
DAX, is it?
Yes.
Does that for you? Yeah. Again, JavaScript. Functional JavaScript. But I picked it up pretty quickly because I'm a coder. So, and I'm not really, the most difficult thing for me to learn was the CSS and learning, it's almost like learning the grammar of graphics again, you know, doing simple stuff well. It's like, you know, not, you know, all right. Go again. Sorry, go ahead. Yeah.
My question is simple. The Crossfilter,
Yeah.
yes, you use is wording node.
Yeah.
So the amount of time taken,
The loading the dating is the hard. The actual Crossfilter will, if you actually look at Crossfilter, where we go.
was it the Crossfilter analyzing the data? Was it reading the data?
Reading the data is what takes the time.
Loading it in the
Loading it is what takes the time. If I can just, I'll pull up this thing here. So this is the that car insurance dashboard. That's it loading. It's loading 200,000 lines into Crossfilter and into JSON. So it's reading probably about a 70 meg file into the browser. So you don't want to do that too often. You know, you can put, you know, this is on my laptop.
So offloading it to
Yeah.
the server would
Yeah.
be pointless
Yeah.
unless you serve it to the user partially. Or
You can do that though. I mean, because the way DC works, you can actually, it basically creates an SVG element, and basically that can be so. So that was the loading. So now you've got 200,000 policies in there. Now, if I want to say, okay, like find me all the family compact cars in there, that's filtered 200,000 records. Bang! Once it's in, it's blazingly fast. You know, and it'll, you know,
From a caching point of view,
yeah.
is this map here is also linked to all this.
Yeah.
So you could start zoomed in, like on your offices or whatever, and then only render those. So you're not actually rendering, and then as this changes, you're sending queries back to the database to load new
Yeah.
data in.
There's a lot of
Probably.
there's some great tutorials on this sort of stuff. It's actually really useful. It's a great skill to have. It took me, because you can communicate quite differently, and you can do stuff that's quite. So it's a really useful technique. I mean, even if you don't use the, you start to learn to think differently, and it becomes much easier to communicate quite complicated things. So I think. I see my son. My son's 13. He grew up with computers. You know, he uses Snapchat. He uses he'll take a video on his phone. He'll edit it on his phone. He'll basically make it funny. He'll put captions on it. Kids, I think these days are basically automatically learning to think visually and use it. So I think there's going to be a lot more of this sort of stuff, and it's going to get, the field is going to get, the competition's going to heat up. Because it's something that I had to learn in my 40s, and it was fun. But I can see my son literally just doesn't even think about it. It's brilliant. And go another one.
I have a question, if I may.
Yeah, sure.
This almost static data. For what other challenges may have arise with dynamic data?
Well, you just, in terms of dynamic data, as in data coming in, as in streams of data.
Yes, streams or based overnight.
Yeah, we have. You can recompute this if you want, or you just basically run it off a database query. At the moment, we've just done this off static data, but you could easily put it through a database. If you have kind of like streaming data, that's actually in the nature of the business we're in is insurance. The touch points are like annually almost. That's not a problem we have, and so we don't. You're asking the wrong person. I mean, we know people who are into Kafka and, but.
Sorry? The Power BI builds this problem.
Yeah.
Yeah. Oh yeah. Like I mean.
You can have a dynamic data.
Yeah.
And it's, again, this technology will move on.
How often you sample it.
Yeah.
It is about dealing with a large data set.
Yeah.
So for example, when you upload even the 100,000 rows,
Yeah.
and you want to do distance-based clustering, that means you got the matrix.
Yeah.
Yeah.
And
Too big.
in this, for example, the R breakdown.
Yeah. Most machine. I mean,
Do
it's
you
very.
have any
Sample.
solution?
Sample from it.
Sample
Sample for your data.
Sample that bad boy.
Yeah. So
That's honestly the best and cheapest and easiest way because that's what statistics is supposed to do.
it's good at that.
Like that is the whole basics of statistics was to infer about a population from a sample. Now the benefit of having really big data is you can actually sample without really losing any inferential power. So you can say if you've got like 100 million rows that you want to analyze over and you can deal with 1 million, well then fit 10 models of those million values and then see if you get similar values. And if you're getting similar values and similar predictions, you've solved an awful lot of your problem because your out of sample problem has largely gone away now. So like there's all like one of the things I heard is one of the luminaries in statistical learning is a guy called Rob Tibshirani. He's the guy who wrote Elements of Statistical Learning. If you've heard of that book, it's very famous book in English. He basically said he had a problem where he was dealing with a large regression problem. He was trying to do lasso on it, which is a type of regularization to prevent overfitting. And the problem was that when you tried to do it on this big full data set, it involved an awful lot of custom coding to get it to work to fit in memory, so the whole thing would work, because whatever data he said. So they did this, and it took about a week of coding, and it ran over about 14 or 15 hours, and then they got the answer. But then just out of curiosity, he took the data, he split it into 20. He didn't do any regularization at all. He fully overfit on each of the samples, and then aggregated all the answer, and he got to within 3 seconds. 3%, and it ran in a couple of seconds, and it took like half an hour to code.
Yes, me, but sometimes even it's a problem that 20% of this data is not even it is to be.
Yeah, so go 1% now.
20% of them.
Yeah, that's honestly, that's what I always do, because at some
That's
point,
what you do.
yeah, generally.
I was looking for too.
Because there's an awful lot of engineering involved in getting big data to work. And also, if you look at, say, MLlib in Spark or anything like that, they're relatively limited in what they can do. Because when you start distributing machine learning algorithms across multiple machines to handle hard data, you basically are restricted to any models that work under MapReduce, right? Because MapReduce is the only real way at the moment. Now, I think there's some work being done on extending that further, but essentially you've got to divide and conquer the problem so that you can split it across 100 machines and get the data back. And the number of algorithms that divide and conquer and MapReduce works under is much, much smaller than what you have available if you can fit stuff in memory. So my first thing always to do is, and you've also got all the engineering involved. Now for me personally, maybe for people like Victor and Georgi who are data engineers, you can run Spark and you can do that very, very simply. But for someone like me, I just don't really know how to do that, and it involves quite a bit of work to get to that point. So what I'll just do is I'll say, okay, well, how many rows can I handle? 1 million? Okay, well, I'll take 1 million rows. And I'll try and do it so that I'm sampling reasonably well across the entire population, so that I'm getting something like a representative sample. And the benefit then is I'll just take a completely different 1 million data points, and that's now my test set. And I don't even really have to worry about cross-val anymore, because I've got so much data, I can kind of pretty much do whatever I want with it, and not have to worry too much about overfitting, because I can kind of I don't have to deal with cross-val or any of that stuff. I can just take 10 different partitions, completely separate to one another, and run my validation models that way. So that's kind of why I think, and the benefits of that are that you can just put something out very, very quickly, and then you find out, okay, well, this is great, but we now need to start dealing with bigger. Now there are certain problems that won't do with that. The guy Hadley Wickham, who's done most of the tidyverse and stuff like you probably know him if you are, he has a really good interview. There's a blog series called Interview with a Data Scientist, and he had a really good one on that, and he talked about the big data issue. And he said there's basically 3 levels of big data where you have basically just fits on RAM, and that's fine. And then you've got fits on disk but doesn't fit on RAM, and then you can sample. And then you've got the truly big data problems where it doesn't fit in RAM and it doesn't fit on disk, and you've got to spread it across. And the big problem is the data is relatively sparse as well. So a recommender system would be a good example by that. You can't really sample recommender system data down and then kind of scale it up. You kind of have to deal with it head on. And that's where you really need to kind of start there with
engineering,
like Spark or Hadoop and spreading your data across. But they're very rare. Like those problems aren't nearly as common as a lot of what other people have to do. I mean, sometimes you just need a classification tree.
I was going to say, I think a couple of weeks of work engineering will save you, at least an hour of thinking.
Yeah. But one thing I do want to make a plug for, we have quite a good meetup scene in Dublin, and we kind of Dublin data science and stuff like that. Some of them are starting to get recorded. We generally didn't record talks because sometimes people say very impolitic things, and we kind of want to encourage that when we're having a meetup. But that's slowly, everyone's starting to record these meetups and put them online, so that's becoming a bit more common. So by all means, just keep an eye out on YouTube or whatever of the various meetup scenes. Dublin data science is the big one we do. I'm not really involved in Dublin R anymore, and we have some really, really good talks. Now they're all in English, but there's generally lots of questions and stuff too, and we'll keep you posted on that.
Okay, thank you very much.
Thank you.
I'm around for the rest of the day if you want to talk.